So we're now going to use the periodic nature of sine and cosine. Earlier, we saw that period, this lambda, that's a Greek letter lambda, for sine and cosine is 2 pi. That's also true of cosecant and secant, but not true of tangent and cotangent. Don't have to memorize that now or know that now. We're going to show why that's true later. But use the periodic nature of this. Well, that means that we could add or subtract 2 pi to find its coterminal angle. So this is equal to sine of 13 pi over 6 minus 2 pi. Well, 2 pi written in terms of 6 is 12 pi over 6. To give us, there's our angle, sine of pi over 6. Now, I love to draw this. Sine of pi over 6, if our angle here is pi over 6, then we know on the unit circle our hypotenuse or our radius is 1. Across is 1/2 and adjacent is root 3 over 2. Notice they're both positive because I'm going to a point, xy, in quadrant 1. So sine of pi over 6, sine of an angle is a trig ratio. I'm looking for the ratio of opposite over hypotenuse, which is 1/2 over 1, or simply 1/2. That's why I say on the unit circle, sine is the y. Now, what if you didn't do that? What if you didn't use the periodic nature? Not a problem. If you're looking at this angle, if we just said, no, let's just keep the angle at 13 pi over 6, notice what we would do. We'd say, let me draw this correctly. A 1, a 2, a 3, a 4, a 5, a 6. That gives us 6 pi over 6, a 7, 8, a 9, a 10, 11, 12. This brings us to 12 pi over 6. Notice if I use my angle and I go all the way around the circle, I've taken up 12 pi's over 6. What is 13 pi over 6? One more. And if we take our baby blue eyeballs and look through our reference angle, pi over 6, we're still going to get this. So do you really have to subtract 12 pi over 6? No, you could just draw your picture correctly and say, my reference angle remains pi over 6 in quadrant 1. Know your magic triangles, your magic right triangles, and you'll see the sine is 1/2 either way. Similarly here, we know the period for cosine is 2 pi. So cosine of negative 7 pi over 2 is the same as cosine of negative 7 pi over 2 plus 2 pi. So I want to bring it to a more manageable number. I could have subtracted another 2 pi or any kind of multiples of 4 pi. I could have subtracted 6 pi or 8 pi or 10 pi, or I could have added 6 pi or 8 pi or 10 pi or 4 pi. I just chose this. You know what? Let's not do that. Let's add multiples of 2 pi. So I'm adding 2 pi n where n is equal to 2. So if I put a 2 in for that, I get 4 pi. I'm going around the circle twice more. So this is the same as cosine of negative 7 pi over 2 plus, if I put this over 2, that's 8 pi over 2, which will give me cosine of pi over 2. By the way, negative 7 pi over 2 and cosine pi over 2 are coterminal. Pi over 2 is up here. If my angle is pi over 2 and I'm on a unit circle, the radius is 1. So I'm 0, 1 for my xy point. Back and forth, 0, up 1. The cosine is the x. So that's going to give us 0. Do you have to do it that way? No. Let's do negative 7 pi over 2. If this is negative pi, and now I'm going this way from my positive x-axis, I'm going negative 1 pi over 2. So this is negative 1 pi over 2. Here is negative 2 pi over 2. Here is negative 3 pi over 2. Here is negative 4 pi over 2. Why does that make sense? Because that's the same as negative 2 pi. If we keep going, here is negative 5 pi over 2. Here will be negative 6 pi over 2. And coterminal with all that will be negative 7 pi over 2. You can see either way, our x, cosine on a unit circle is the x, will be 0.